Good afternoon. So thank you for coming for this talk. So I'm Patrick Masse. I'm working for AMD as Solution Architect Pre-Sales. And I will show you some key points that is important to have in mind when you where you want to ensure that is well up to date with regard to your servers, your CPUs in particular. So in all our infrastructure, and we are here in VMware Explore, for sure you know about virtual machines, which are providing you a way to isolate your workload with their own guest OS and set of dependencies on top of your hypervisor of choice and host operating system. Is great from a let's say portability standpoint because your virtual machines will run on the same hypervisor elsewhere. It's a way to, let's say, control your dependency in the same virtual machines, but has some drawbacks. You have the size of the virtual machine image. You have maybe the time to spawn the virtual machines that can be more than 10 seconds or minutes, depending on the workload. It's not the case with containers, which, as you may know, is composed of lightweight container images that includes just your app and just your dependencies that you just need in your for the given workload. The container instances will run on a given container runtime. Let's say run C, CRIO, for example, and on the same host operating system, sharing this operating system services, so the access to the hardware, the storage, and the network. The key points about containers is, as I just touched, is lightweight. They are lightweight piece of code, being binaries. And so in terms of storage size, they are smaller. One. Secondly, they can be spawned really in less than 1 second, which is great to have to launch and stop in a very easy manner, in a fluid manner. And that makes the containers great for what we call microservices type of applications. That's the first top use case where you will see containers out there. For this distributed applications, which is composed in a set of what we call loosely coupled subparts implemented as microservices, meaning subparts implementing, for example, just the access to the network or the front end, name it, okay? That would be accessed via interfaces such as APIs, okay, remotely in a loosely coupled manner. Or implementing those subparts, microservices, as containers is a great way to scale in an easy manner and to stop and start subpart of your application really in an easy manner. Another great use case for containers is the fact that, and if you are implementing that as per cloud native principles, you would have coded your application with pure code and separating the configuration in clearly defined configuration provided by configuration files or configuration services in a cleanly separated manner, such as the same code can be run in different environment that will be configured in a different manner, which is great when you're automating your own, let's say, quality and assurance pipelines, which means when you're implementing continuously, integrating your systems, continuous integration, and continuously deploying your applications on the different type of environment that you may have that will be configured in a different manner with the same code if it's not needed to be fixed. In a way that will be, again, very efficient because those containers can be really, it's a less than 1 second spawning. I just mentioned development, build, test, deployment production environments. Are the ones that's the typical type of environment that we would have in CI/CD. Those environments can be your laptop, on-premise, or in the cloud. That's where containers are great nowadays to implement in an easy manner, again, with the thing that you're letting you, as a developer, to focus on your application, not on the infrastructure. And doing that in a different type of OS, meaning that in a portable manner, your Linux containers is just one thing that you need to have in mind, is that your Linux container needs to be deployed in another Linux container environment. For Windows, you will need to have a Windows component, because as I mentioned, all those containers are sharing the same operating system. That's one of the other differences that you have between virtual machines and containers. I just mentioned that all this is really designed for you as a developer, or you as an operator, a DevOps operator, to care less about the infrastructure. But you may want to know that having in mind the performance of your processors, of the type of I/O bandwidth that you have available in your infrastructure, on the storage side, on the network side, can be interesting for your final workload. And you can trust AMD, which, as you know, is delivering to the community since 2017 EPIC processors that are scaling very well. We are now in the third generation of EPIC, still having the 7 nanometer in terms of process. And we are moving, as you may know, we are about to launch our fourth generation EPIC, the 10th of November, so just this Thursday, where you will see the great new features that we are providing. For example, just to name one, currently we are providing a high density types of core, up to 64 per socket. That's the third generation, okay? With the fourth generation, we will go up to 96 core. And we will continue to move actually in terms of density, and a bit later, we will provide another package. We will have 128 cores per processors. That's one thing that is important when it comes to containers, where you are leveraging the cores for your actual workload. And the more dense, the more containers you will be able to run on the same server. Up to 60% compared to our competition, having the third generation in mind, and also the fourth generation. With the coming fourth generation of our competitor, we will have still 60% more core to provide to you. That's great, and you can trust that as per our third generation, we have more than 250, let's say, world record in terms of performance. We will have more to show with our fourth generation. And to complement to that, still in the virtual machine and container type of setup, we have great security type of use cases to show you. This is coming with AMD Infinity card, which comes first by the support of secure boot. One thing, that's classic. But not only, we have also secure memory encryption, which allows you to dynamically encrypt the memory at host level. And we will have improvement at the fourth generation. You will see that soon enough. And in terms of virtualization, we are supporting, and that is supported in vSphere up to 7.0 update 1. So since a while now, you can leverage with VMware and vSphere what we call secure encrypted virtualization, which allows you to isolate your virtual machines with its own key. And this key stands only in your processor. And this will work with any EPIC processor, whatever let's say, the type of parts. Each key that is, let's say, allocated at the secure processor level in your processor will be allocated to dynamically encrypt the memory of the given virtual machine instance in a unique manner in order to protect the given machine from the other virtual machines, from the hypervisor, and from the guest OS, and for sure from any external accesses. So this is something that you can leverage without any change in your workload in terms of code, and really minimal impact in terms of performance. When I say minimal, is in the majority of the case, less than 2% in terms of performance impact. That's virtual machines. And we are leveraging that with vSphere, with Tanzu, which implements vSphere pods, where, as you may know, allows you to have Kubernetes pods which can include one or more containers at the vSphere pod with just the addition of an annotation telling that your given pod would require to be confidential. Okay, then you will leverage the feature that I've just explained for your pod, and then that means for all the containers that are executed inside. Again, with no change in your containers in terms of code or binaries, and really not much differences in terms of performances. So in terms of infrastructure, it's important for you to know in terms of Dell, so working with Dell in particular for that. So we have the set of VXL appliance that is based on AMD, and which are great in terms of single sockets. We have, thanks to our density in terms of core that I mentioned previously, we are very performant in terms of with only one socket. Okay. So the VXL E665 appliance is a great, very efficient single socket appliance, and also this one is also single socket with more storage. And you can have a look at just a full set of vSphere and vSAN ready nodes with either monosocket or dual sockets with AMD CPUs that are noted here, which are already around today. And just to conclude, here they are already included, including vSAN 8, and Express storage architecture. So you are all fit with Dell and AMD to modernize your IT infrastructure. Thank you very much.